Hello everyone, and welcome back to the simple third-person platforming series. Today we will be covering a few core mechanics of platformers, namely velocity retention upon jumping and wall jumping. So let's get right into it. Let's hop into Visual Studio here. First thing we're going to need for velocity retention is the ability to actually save the character's velocity. Of course, the character controller has the dot velocity thing that we looked at previously, but as we saw previously, that leads to some issues. So we're going to create our own velocity variable. And since it has to be tracked between frames, we're going to create it up here. So, vector3, velocity. And let's hop down here. And we need some way of setting the velocity, and the way that we want to set velocity is by looking at how far we move it. In this case, my controller.move my vector, but we want the actual speed of it rather than the amount it moved during the frame. So up here we multiply our vector by time.delta time. What we want is its value before multiplying by time.delta time. So after everything right here, we're going to divide my vector by time.delta time and store it to velocity. So we go velocity equals my vector divided by time.delta time. And just to see what that does, let's go ahead and say print velocity and see what happens. So if our move speed is, see what we have it set to. If our move speed is 3, we should expect to see things in the console here that have a magnitude of 3 when moving anyways. If our keyboard's in the right mode. And you see there's a negative value for y. That's because that's being handled separately. And indeed we do see, if we unclaps this, values that add up to about 3. So you see right there? Alright, so now that we've confirmed that that's working properly, let's go ahead and find some way to incorporate this. We want the character's velocity to be retained after they jump into the air. So this means we need another variable for storing the grounded velocity. So let's hop back up here again and type out vector3 grounded velocity. And then down here where we check to see if the character is grounded or stuck to the walls, which we're going to change in a second, we set grounded velocity to velocity. Alright, but now we want to separate the walled state into a separate if statement, because as we saw before, we have that odd behavior where as soon as the character hits a wall, they start moving down, and if you try to wall jump, then they kind of just jerk upwards. So let's else an else if statement. An else if statement is like an else, except for it has an additional if statement that constrains it. So an else if will be executed only if the original if statement is false, and the statement within the parentheses after the else if is true. And then after that, if none of those have been evaluated to true, then the else statement will be executed. So right here we want to do flags and collision flags dot sides is not equal to 0, and make sure that we put it in parentheses because order of operations. Alright, and add in some braces there as well. And we need to return this to its original state, so we just want it to be collision flags dot below. We don't want to check if it's colliding with a wall. There we go, perfect. Alright. So in its current state, we're setting velocity every single frame, and if it's on the ground, then we're setting grounded velocity to the value. Also, we need to make sure that we set can jump to true in our wall collision detection here. So can jump equals true. Alright, and hit save. Let's hop into Unity and see what happens. The answer should be nothing if we didn't mess anything up. Alright, so yep, no difference right now. Except the wall jumping should be different. So now we can continually jump up one wall. However, if we spam the spacebar in air, then we don't get like a repeated jump midair. Hopping back into Visual Studio, we need to have some way of using our grounded velocity to drive the character movement while they're in the air. So if the character is airborne, we want to use the velocity that the character originally had while they were on the ground, and that will be retaining their momentum from when they jump. So instead of using our input to drive the character, instead we want to use the grounded velocity. So around here somewhere, we need to change my vector so that instead of pointing to the input, it points to the velocity. So let's try something here. Let's do if, well, we're going to check if the character is grounded here. So you might think we have to do all this stuff again, but character controllers actually have an easier way of checking if a character is grounded, and that is with the character controller .isGrounded property. So if we do if my controller .isGrounded and add in some braces. So right here, if the character is grounded, then my vector is being set to the input. Otherwise, else, let's have my vector be equal to the velocity, or grounded velocity rather. However, right here where we multiply by speed and time.delta time, that would need to be up here as well, because we don't want to reapply speed and everything to the velocity that we already have stored that we know is correct. However, we do want to apply time.delta time to it. So we'll do my vector times equals time.delta time. And again, the something equals operator is just the same as my vector equals my vector times time.delta time. It's the same thing, just a more shorthand way of doing it. So let's hit save and see what happens. You'll notice some quirky behavior coming up here. Alright, so we run and we jump, and well, it kind of went off in the opposite direction. Let's try that again. Let's try going right. Well, that seemed to work fine. And left. Left works fine. But if we try jumping up and down, some odd behavior happens. So let's look at what we're doing to the input. Right here, we are rotating the input by the rotation of the camera. So that needs to be done only if we're using the actual player's input rather than the grounded velocity. So let's move this up into the if statement as well. As well as this. Okay. Now let's give it a shot. And save. Oh, there we go. We have momentum retention. So now as soon as we hit space, the character is locked into a predetermined jump trajectory. But they can still jump up one wall. So we need to find some way of figuring out what happens when they touch the wall. So we already know when they touch the wall, but we don't know what to do with that information besides making it so that they can jump again. What we want to be able to do is make it so that the character jumps off the wall. They jump away from the wall. And that actually gets a bit more complicated. We need to use another feature that the character controller provides. And if we look at the Unity scripting API right here, hold on, there we go. Character controller.onController collider hit. It's another thing similar to the onTriggerEnter that we did back in the second video, except for in this case, instead of a collider, it has a controller collider hit right here. So the way we access this is by mimicking the same way that it is used here. So we have void onController collider hit, and then controller collider hit, and then braces. So let's just do that back in Visual Studio here. We need to do it outside of the update method. So let's hit enter here and we do void on controller collider hit, and then controller collider hit, which is a type, and then we give it a name. The name, again, doesn't matter, it's just something that makes sense. We'll call it hit. And then braces. So what happens if we type out hit here and hit dot? We get a couple of options here. So we've got point, normal, rigid body, move direction. The one we're going to be interested in normal. So what is a normal? The normal of the surface we collided with in world space. Well, just for a simple drawing, let's hop over to Psi here. So say we've got our character controller. This is a top-down view, so our character is circular here, and we've got a wall right here. And the character is moving this way, and they strike the surface right here. The part that they hit, that's stored as the point in the hit dot point. The direction that the surface is facing, like that, is stored in the normal. The way that the surface faces is called the surface normal. So that's what we want to get. We somehow want to use the normal to determine the direction the wall is facing, and then somehow use that to determine how the character will jump when they try to execute a wall jump. So back into Visual Studio. Let's just store the normal as a temporary variable. So we'll create a vector3 normal equals hit.normal. So this will just be a more shorthand way of accessing it. Now we can just hit normal and we have instant access to it rather than having to type out hit.normal every time. And we need to do something to the character's grounded velocity. Because the character is always moving in the direction of the grounded velocity, we need to turn it around so that the character jumps away from the wall. And the way we want that to happen is, say we've got a wall right here and the character's here, moving that way, and they input a wall jump. We want them to jump off like this. We don't want them to head straight back the direction they were going. We don't want them to head straight away from the wall. We want them to kind of reflect off the wall. So here's the surface normal right here, and we want the vector, their movement vector, to reflect off of it. And conveniently, we don't need to do a bunch of trigonometry for that. Unity has a built-in thing called vector3.reflect. So let's try this. We'll type out vector3.reflect. So it takes in an indirection, and we will use grounded velocity, because that's the direction our character is going to be heading. And for the normal, we want the normal of the surface, so normal. But what do we do with this? So we now have the value, but we're not doing anything with it. Well, let's reassign it to grounded velocity. So the value of the reflected vector, we then set back to the grounded velocity variable. Equals. What's wrong with you? Grounded velocity. There we go. I can spell. Alright, now let's hop into Unity and see what happens. That's not Unity. Alright. And hop. And nothing is happening. Oh, we do get a bit of a bounce right there. So we just kind of bounce off right there. You see that? I'm not doing any input. The character just kind of bounces off the wall. Alright, also the character's moving kind of obnoxiously slow. Let's update the speed. We'll say they move 6 units per second. And let's increase the gravity a bit too. Let's set that to 13. It's not real, but it might feel a bit better, so let's try it now. Whoa, yeah, there we go. That's more like it. So now we've got that bouncing action, but we don't have any like vertical movement from the jump. And we want to be able to say, actually, let's create a goal. So originally we had the star here. Let's create a wall jumping goal. So we're going to have 2 large walls here. And let's increase the size of this plane. And increase the size of this. Thin it out. And let's create a raised platform. Duplicating this, slide it up, put it over here. Slide it in. And let's grab the star here. Where is it? Star, there it is. And move it up on top of the platform. So we have to be able to wall jump in order to get to this, or we can increase our jump height drastically. But our goal is to be able to run up here and jump back and forth off each of these walls so that we land up here and collect the star. Let's actually increase the size of this a little bit because we don't want to overshoot. Alright. So we want to add some bit of vertical movement when the character does a wall jump. However, at the moment, in addition to not getting that vertical movement, we're also just automatically causing them to wall jump rather than actually doing it when they press the space bar or the jump button, whatever they have it mapped to. So rather than instantly setting the grounded velocity to the reflected value here, let's instead store the normal and then access it up here when we're looking at if they're on the wall or not. So rather than declaring the normal variable here, let's declare it up here so that we can access it elsewhere. So vector 3 normal. And then right here, we say normal equals hit.normal, and then grounded velocity equals vector3.reflect, but we want this to go elsewhere. So let's cut that. And we want it to be executed when the character presses jump. So let's paste it somewhere in here. And we only want it to be executed if the character is on the wall. So let's go ahead and check if they're on the wall. However, you'll notice that we're actually checking if the character is on the wall down here. We don't know if they're on the wall up here yet. So we need another variable that lets us know if the character is on the wall. So let's do a bool, a true or false value, on wall. And set it to false to start off. Its default is false, but just to make it clearer. And then down here we say on wall equals true, and otherwise on wall equals false. And if they're on the ground, we also want on wall to be false. So on wall equals false. So the only way that on wall will be true is if the character is only colliding with the sides of something. So let's hop up here and then do if on wall grounded velocity equals vector3.reflect. And again, it only happens if the character has input the jump button. So let's save and hop into Unity. Hit play. Alright, there we go. So normally if I hit the wall, I just slide down. But if I then input the jump button, then we get that wall jump in action. And you notice it retains its momentum slightly. Like if I'm holding forward when I first touch the wall, then it will continue going forward. And let's get a bit of a better camera angle actually. So let's do right here perhaps. Game object, align with view, and also to make it even clearer, let's use a trail renderer. So let's select our character here and add a new component, trail renderer. Trail renderer. Alright, this will let us see the path that the character takes. So time is 5 seconds, that's how long the trail will last. Colors don't matter. And materials, it starts off as null, so we just want to use the default particle value. And let's go ahead and hit play. Actually, let me show you what happens if we don't have one of those attached. And it's the most beautiful color in the world. Ah, yeah. Using Unity, you will come to hate this color. This color is literally the devil. But if we start doing some wall jumping, you see it follows the path that the character takes. Even in 3D, see how we started right here and we kept our velocity going in this direction and it kept just bouncing off the walls. Alright. So you'll notice even though we're not actually telling it to go up a little bit, it actually is going up. As you saw in the path there, hold on, I probably should have showed that before I hit stop. If I hop against the wall here, you'll notice it actually has a bit of an upward arc. So right here, we jump from here to this wall, and then when we jump off, we go back again. And that's because we actually have a negative value for our grounded velocity. You see, most of the time when our character is just there, we have a negative value for our vertical velocity. And that's because we're saying if they're on the ground, vertical velocity equals -3. And we want grounded velocity to ignore vertical velocity. So, right here, where is it? Grounded velocity equals, we're going to use our project on plane method again to exclude the vertical component from velocity. So we do vector3 dot project on plane. Again, it takes in the input vector first, which in this case is velocity, and then the normal of the surface, or the normal that we want to exclude from the vector, and in this case this is vector3 dot up, just like before. Vector3 dot up, capitalized, Zector. Alright, so now grounded velocity should ignore any vertical velocity that's in the equation. So let's hit save, hop into Unity, and now we should not have the actual vertical momentum added to it. So let's go over here, and indeed we do not have any more additional vertical velocity being added. Or do we? If you take a look right here, we actually do have a bit of an upward arc. Interesting. So let's hop back into Visual Studio and see what's going on. So this actually wasn't what was causing the issue. This could have caused issues later with our negative velocity being applied. However, that wasn't the case in this case. Instead, right here, we're simply checking if can jump and then adding our jump speed to vertical velocity. This happens whether the character is on the ground or on the wall, which is actually the behavior that we wanted, but accidentally implemented. So that's all working fine and dandy. Before we move on, let's change our trail from the non-nightmare color. So let's grab my character and change the material to something else. We'll say default particle and change the width to something like 3, or not 3. 3 is oftentimes greater than 1. Apparently I didn't learn that in school. Alright, so let's hit play and try this again. Alright, so we're jumping back and forth. Oh, almost made it up. Let's try that again. Let's actually add a bit of jump height to it just to see how things work out. Let's see here, jump speed 13. Let's go. Alright, alley-oop. Oh, and there we go, we made it to the star. Wonderful. However, there is a bit of a problem right now with the current mechanics, a problem or design choice, and that's that after you jump, you're locked onto your path. Like I'm holding to the right now, and it only starts going to the right after it touches the ground. We want the character to at least have some control over their velocity while they're mid-air, even if they can't entirely reverse their direction. So, the way we're going to do that, if we hop back into Visual Studio again, is by retaining the character's velocity while mid-air, and then adding a little bit of our input to it. Not the full speed, but a different speed that we can set right here. So public float aerial speed. Alright, and we'll set that to a default of 2. And hit save. So right here we do my vector equals my vector times speed times time.delta time. Let's move that out of everything right here. So after this, we don't want to include speed right here though. However, time.delta time we do want. We're applying it right here. Since we're applying it outside, we don't need to do it again. So delete that, remove that. Alright. So we need to multiply the result of my vector now by something. Let's back it up. Everything I did just now was just for simplification. It didn't actually change the behavior much, except for we removed speed. We need to add that back up here. My vector times equals speed if it's on the ground. But if it's in the air, we want to have a bit of control over the input. So if it's not grounded, that means it's in the air. So right here, we need to do something with the input. However, our input is inside this if statement right here. Instead, we want to be able to access that here. However, we can't right now because it's up here. But if we move it outside of the if statement, so that it gets executed no matter what, and instead of assigning it to my vector, let's assign it to new variable. Let's say vector3 input, and then right here, input.x and input.z. And then when we clamp the magnitude, we want it to be clamping input, not my vector. And we want to move that out as well, of course. Input. Alright. And then in here we say my vector equals input equals input. And then we do the rotation, and then we multiply my vector times speed. And then right here we assign my vector to grounded velocity, but instead we want to include our input as well. Use of unassigned, we need to initialize this to vector3.0. Vector3.0 is just shorthand for this. So we can even replace this up here with vector3.0 as well, vector3.0. Alright. And let's go ahead and move these back a tad. There we go. And add a space in just for clarity. So right here we need to somehow incorporate the player's input with the grounded velocity. So let's try the most basic thing and just say my vector plus equals input. And plus equals is the same as equals the original plus the value. So plus equals input, and save that, and let's see what happens. It should actually seem fine, or at least passable. There are a number of issues, one of which some of you probably noticed. So we actually have some control over it midair. As you see, I can move it faster or slower. And when going faster, it actually seems to be going much faster. Faster than it actually does on the ground. But before we tackle that, we need to make sure that we actually make it move by the airspeed. So right now we say plus equals input times airspeed times airspeed. Or what did we set it to? Aerial speed. Excuse me. Aerial speed. There we go. Alright, so now we can set that freely in the inspector here. Right here. And let's set that to 3. Alright, so now we can move and direct our movement slightly. Perfect. So if we jump straight up, then we can still move side to side a little bit. If we jump forward, we can move side to side a bit. And while we're wall jumping, we can slightly adjust our movement so that we don't overshoot things and land perfectly on the platform. Wonderful. However, if I hit play again, you'll notice something. If I'm running and then I jump, it seems I begin to go faster, and if we look down at our velocity right here, you'll see it jumps up to 9 in x. And 9 is a lot greater than our grounded speed and our aerial speed. And that's because we're inheriting our grounded speed and then adding our air speed to that. And 6 plus 3 is 9. You can confirm right here, 6 and 3. So let's hop into Visual Studio and think about what we can do to solve this. In this case, what we want to be able to do is make it so that the character's velocity doesn't exceed their maximum grounded velocity. So we already know how to make it so that a vector doesn't exceed a certain value, and that's with our clamp magnitude method right here. So outside right here, let's do my vector equals vector3.clamp magnitude, my vector, and the max length we want to be ground speed, or just speed. Also, to clarify things, let's go ahead and rename speed to ground speed. The easiest way to rename things in Visual Studio is to hold Control and tap R, and while still holding Control, tap R again. And that brings up this little prompt right here that lets you rename everything at once. Ground speed. Alright, so now we have ground speed and aerial speed. Hit save all. Hop back into Unity. Hit play. Oh, it is worth noting though that it resets. If you rename something, then it loses its original value in Unity. So, setting it back to 6. Now let's try it. So we run and we jump, and confirmed it does not increase past our original max value of 6. So now we don't have any speedrun strats of just jumping repeatedly so that the character moves faster. But we still have our ability to control our jumping and our direction mid-jump. And that's going to be it for this video. In the next video, we will actually take care of importing an actual character and getting them to animate. So that's going to make things a lot more visually appealing, and it's going to be fairly fun to do. Not much coding involved. But yep, until next time, thanks for watching. Actually, I lied. One last thing. There is a bit of a quirk right now. And that is, if we jump at the wall with a low velocity, we can actually continually jump against the same wall because our aerial speed is exceeding our grounded speed, which means we have more control over our velocity in the air and can completely reverse our direction. So the way we're going to fix that, hopping into Unity really quickly, or not Unity, Visual Studio, is when we do the wall jump, right here, rather than just reflecting the grounded velocity, we're going to normalize it, which means making its magnitude equal to 1, so its length equal to 1, dot normalized, times grounded speed. And hit save. And that'll make it so that we always jump off the wall with a uniform velocity. So, let's see if it worked. It did not. Uh-oh. Uh-oh. And the reason it didn't work is because we are doing this based off the grounded velocity, and if we jump straight up without moving in any direction, then our grounded velocity has a magnitude of 0. So instead of using the grounded velocity, we want to use the actual velocity of the character. So rather than grounded velocity right here, let's take in velocity. Velocity. How to spell? Velocity. There we go. Alright, now let's hit save. Hit play. Alright. There we go, that's better. Now no ability to repeatedly jump off the same wall, no matter how hard you try. Unless you approach the wall from a very low angle, in which case you can continue jumping up the wall as you saw before, as well as there's a bit of, there's a bit of altered vertical momentum when hopping up the wall. And that's because, back here, we are setting grounded velocity to a value that includes a y component, or vertical component. Right here we're excluding it, but right here we're not. So we need to exclude it again, just as the first issue to take care of. Vector 3 dot project on plane, then that value, and then vector 3 dot up. But we also need to make it so that the character cannot simply steer back into the wall no matter how shallow an angle they hit it at. So they need to be moving away from the wall at least at the velocity that they are able to control their momentum. So in this case, aerial velocity. So we need to make sure that the value that we set grounded velocity to is pointing away from the wall, at least aerial velocity. So you'll notice things are getting kind of complicated here. So let's actually split this up. Let's create some braces here. Put that on a separate line. and separate this logic into a couple lines of code so that it's easier to read. So the first thing we need to do is vector3 reflection equals vector3 dot reflect, not reference equals, reflect velocity normal. And then right here we instead replace this with reflection. Hit save. And then we should probably simplify the projection as well. So vector3 projected equals vector3 dot project on plane reflection vector3 dot up. And now we can remove the project on plane method from right here. And instead of reflection there, we use projected. Projected times ground speed, projected dot normalized times ground speed. And now we just need to ensure that it's at least pointing aerial velocity units away, or aerial speed units away from the wall. The easiest way to do that is to add the wall's normal to it. Even though this can cause some issues with the grounded, or with the speed exceeding the normal maximum grounded speed, the alternative requires a bit of trigonometry, which is a bit out of the scope of this. And it actually adds a bit of interesting speed tech, whereby bouncing off a wall you can go faster than if you were just running normally, which is really cool. It adds a lot of depth to the game. So we'll just say plus normal times aerial speed. Alright, let's hit save and hop into Unity and see what happens. Beautiful. Uh-oh. Alright, and we went off the edge. And no matter how you approach the wall now, there should be no way to repeatedly jump off the same wall, as you can see there. Perfect. Alright, until next time, thanks for watching.